Okay, welcome to the physics class. This is the potentiometer practical. Under this experiment, you are going to find out the internal resistance of a voltmeter. So, as you can see, my circuit arrangement here, there is a resistance box, a galvanometer, a voltmeter. We have a switch, a cell, jockey, and the potentiometer, together with the connecting wires. Okay. Note that in the potentiometer we have two circuits. Circuits one here, which consists of the resistance box, galvanometer, and the voltmeter. And the circuit number two consists of a cell and a switch, all connected at these points at the ends of the potentiometer wire. Okay. So we have been connected this circuit according to this diagram as it is shown in this question. So how can we do? The question said that set R at a value such that a voltmeter is 1.0 volts and obtain the balancing point C on the potentiometer wire. Record the values of V, R, and L. So we are going to set the resistance. Set resistance such that the voltmeter reads 1.0 volts. So find out until you have 1.0 volts. Okay. According to me, at this point, my voltmeter is 1.0 volts. After then, find out the balancing point. So, I'm finding the balancing point on the potentiometer wire. Okay, it balances at this point. So according to this diagram, from the end of B, you can take the measurement until the balancing point is. So here, as you can see here, this is A, this is B. So from B to the balancing point, to the point where I can take my reading. So at this point, the reading starts from B to this point. Okay. So we can continue until the value of 0.3 volts, from 1.0 to 0.3 volts, as you can see from my table of results here. After obtaining the values, then tabulate your results, as you can see here, by considering the measurement of each physical quantity. So after obtaining the table of results, then draw a graph. As you can see, my graph here, a graph of R against L over 100 minus L, as it indicated on the question here. Plot a graph of R in vertical axis against L over 100 minus L on the horizontal axis. After obtaining the graph, then determine the slope of a graph according to the question here. Then we have really indicated the slope of a graph by dotted line, indicating the right angle here. Remember to write the change in R, the change in L divided by 100 minus L. Indicate the axis. Remember that these two two lines where intersects, make sure that the two lines intersect by extending the lines downward and leftward. Okay. Remember to indicate 0 at the meeting point. So this is the nature of a graph. After then, the question says that if RV is the resistance of a voltmeter, obtain the formula for balancing bridge in terms of the balancing length L and the corresponding resistance R. As you can see this diagram, this circuit here, resistance R from the resistance box is direct proportion to the length. Direct proportion to the length, as you can measure from this side to the center. So this length of resistance is proportional to the length, and also RV, the resistance of a voltmeter, could be proportional to the remaining length here. So from there, we are going to deduce the formula. Before that, we are told to find the slope of a graph. So from the graph, slope can be obtained by taking the points. These are upper points and the lower points on the vertical axis, and the upper points and the lower points on the horizontal axis. So slope here you can determine as change in R dividing by change in L dividing by 100 minus L. This is the remaining length. This is in ohms. This has no unit since the ratio of the length. So here we have, according to here, it is 900 minus 400 at this point. Then you can take here 2.4 minus 1.04 at this point. After then, a slope of a graph, it is 605.80 ohms. So this is the slope of a graph. The question said that if RV, the resistance of a voltmeter, obtain the formula from for a balanced bridge in terms of balanced length L and the corresponding resistance R. So we are going to develop the formula. If R is direct proportional to L, then RV is direct proportional to the remaining length. This is 100 minus length L. So from the expression number 1 here, we have R, which is equal to KL, call it equation 1. And from RV is equal to K 100 minus L, call it equation 2. After this, divide equation 1 and 2. If we take 1 dividing by 2, here you can have R dividing by RV, dividing by KL, dividing by K, 100 minus L. K and K cancel out, so here R could be equal to RV, L dividing by 100 minus L. So this is the required equation. So from this point D says that the formula from the formula C above, and then the graph, calculate the average value of RV. So as you can see here from the formula, if we equate Y is equal to MX plus C, so here you can see that RV is the slope, whereby R is the corresponds to Y, and X is the variable, which is L dividing by 100 minus L. C, this is 0, intercept of the graph. As you can see the graph here, the graph has no intercept passing through the origin, so which corresponds with this equation. So RV is the slope of a graph, which corresponds to the slope of the equation. So from the graph, slope was equal to 605.880 ohms, which is equal to RV. So RV is the resistance of a voltmeter. This voltmeter which have been used has a internal resistance of 605.880 ohms. E. Name two sources of error in this experiment. Two sources of error in this experiment. Errors in this experiment. Error due to parallax. We were reading reading on the meter rule. So you are required to read it perpendicular to the point which you are taking, in order to avoid the parallax error. Also, in case of the voltmeter, parallax error can be developed. Also, on the reading of the galvanometer, the parallax error can be developed. Another one is the graphical error. When you draw the graph, consider that the graph must pass through many points as possible in order to have the best fit in line. Also, polarization of the battery. Polarization of the battery can be a source of error. When you remain the switch in contact for a long time, there could be polarization of the battery, which can bring up to error. Also, the heating on the potentiometer by passing the current. Whenever the current is passing, since there is a resistance, can develop heat. So that heat can affect the results, the final results. Okay, so all of these are the sources of error can be discussed in this experiment. You can find another one by yourself. Okay, thank you for watching. Welcome again.